I've just come to the realization that this bloke's study is really similar to my setup, and I kind of want it to be setup goals. Down to the coffee cup. Anyway, we're starting a new topic, and I'm going to start by, oh my god, my thing's on 2%. One second. Oh no, reach. Am I going to break something? Well, I guess you're not looking at my head anymore. What was I even talking about? Okay, we're starting a new topic. What a waste of a minute. Starting a new topic, we're going to look at something we've seen before and then something we haven't seen before. So the thing that we have seen before is something called direct variation, and it's just straight lines. So direct variation is when you've got two variables, so we just look at things that are like x and y, that are directly proportional to each other. That happens if one is a constant multiple of the other. So a couple of things you can take out of that. Directly proportional means that if I was using y and x, I can say that they're proportional to each other. That's what that symbol means. That's proportional. I don't like how close that is to the text, so you can move. I don't want to move it. Okay. Now, when two things are proportional or directly proportional, that just means y is equal to some multiple of x. So this could be a half, that could be 5, that could be anything, as long as it's one thing. So if I were to graph this, like if you think about y equals x looks like this, y equals 2x looks like this. There's a few things you can take from these graphs straight up, and the first thing is that they always cross the origin, and that's because the origin is the point 0, 0. If I put 0 and 0 into there, it's going to hold no matter what k is. The second thing is that they're straight lines, so direct proportion means a straight line, and what else? That's kind of it. So when something's considered to be in direct variation, that just means that as one thing happens, the other thing happens at the same rate. So in other words, if I were to double y, then x is also doubling. So if that was a 2, that would mean pretty much that. Now, it doesn't have to be both going up. So this is kind of suggesting that as one thing goes up, the other thing goes up. This might be as one thing goes up, the other thing goes down, but at the same rate. So if this was like -2, this would be doubling and this would be halving perhaps. But direct variation, as soon as you see a question that says direct variation, you should just think this should be your first line of working. A question will give you x's and y's or different letters or whatever, but that should be your first step. Okay, so I guess a couple of things I was going to write a couple of things, but I think I've said it. This statement basically just says, whoops, y is directly proportional to x. I don't know why I did a bracket there. Okay. Is there anything else I want to write? No, everything I pretty much just said. Okay, so I guess we'll go through a question. The distance in meters traveled by a car is directly proportional. So that means as one thing goes up, the other thing goes up as well, to the number of rotations of its tires. So there's a lot to unpack there, but basically as a car drives, here's a car, as it's driving, the distance it travels, so the further it travels, the more the tires are going to rotate, which makes sense. The further you go, the more your wheels are going to rotate. That's directly proportional because as one thing goes up, so this could be the distance I travel, as that goes up, obviously the amount of rotations my tires do also goes up. And at 0, 0, so when I haven't traveled anywhere, no distance, I'm also going to have no tire rotations. I hope that kind of makes sense. So that's directly proportional. Now I'm going to start naming things. Let's call the distance D, let's call the rotations R, and let's figure this out. So these questions work exactly the same every single time. You're trying to create a variance equation, which is just my y equals kx. I always just start with that. Then I just replace it with the stuff I've got. I don't have y and x. I've got d and r. It doesn't really matter which one you put where, d or r, or if you do r and d, it doesn't really matter. You're just going to end up with a different k value. Some things might ask you, so some things might say, give me an equation in terms of r. That means that your right-hand side of the equation has to have an r in it. That's all that means. But essentially, you're just putting d and r wherever you want. Doesn't really matter. I guess you could just think about, like, this is normally the independent variable. So which one's independent, the distance or the rotations? Like, the more rotations, the more distance, or the more distance, the more rotations. Like, they're independent of each other. It doesn't really matter. So I'm just going to do it in alphabetical order. D and R. What did the textbook do? I better do it in the same thing as them. I hope. I haven't even written the full question here. What an idiot. Yeah, they did do that. I haven't written the whole thing. Give me a second. Let me move that down. Maybe skip 30 seconds. Okay, that's it. Oh god. Oh god. Go back. Okay, so these questions always are the same. They'll say it's either directly proportional, then they'll give you two values for each, then they'll ask you a bunch of questions. Every single time, it's always the same structure. So what you're going to do first is you're going to write down what you want your equation to look like. So what I want my equation to look like is this d equals, oh my god, work. I just want you to move you up. I just want to look like this thing here. That's my blank equation. Now what I need to do is figure out what my k value is. Now I didn't actually write this, but this here is called the constant of proportionality. So what that means is, how are x and y related? So if as x is doubled, no, sorry, if y was doubled or something like that, then k would be 2. So like, I don't know, for every goal I score, someone else scores 2. Those two things are directly proportional, that k would equal 2. That's my constant of proportionality. So it's the constant that tells me how proportional these two things are. So that's the first thing I need to find. And that's quite easy because a question normally at the very start will give you a value for each. So they give me an r and a d value, an r and a d value. So the first thing I'm going to do is substitute those. So d is 900, distance is 900, when I've done 540 rotations. Now it's quite easy to find k, it's just 900 over 540, which is equal to, I know they're both divisible by 9, but oh, I'm having a shocker. The question has 950 in it. Does it really matter? Probably not, but I don't have to work this out on the fly. Okay, so that's around about 1.759. Let's call it that. 1.759. So that's k. So once I have my k value, what I can do is I can write my equation. So maybe I'll just do that. I can write my equation. And that is the equation I use for the question now. So I now use this to answer what the question gives me. So it's asking me what distance will be traveled after 800 rotations. So now that I actually have an equation, I can start substituting into it. I know how many rotations there are. I have r here. So when r equals 800, that just means d is equal to 1.759 times r. Are these dot dot dots confusing people? I hope not. So let's just do that. Okay, and that's just, oh, and substitute it. Times 800. That's equal to 1407 off the top of my head. The distance is in meters. Okay, and then they just ask you the reverse. So how many rotations to cover 360 kilometers? So that was A. If I do B, so they've told me what D equals, 360. When D is 360, what's r? Well, that's 360 equals 1.759. So instead of timesing, I'm going to have to divide. So r is going to be equal to 360 divided by 1759. And that's around about equal to 204631. 204631.578. Okay, this is where I'm going to disagree with the textbook, because they've said, the question says full rotations to cover 360. This suggests that I have to do that and half a rotation to get to this. So if I were to do less than this, then I don't actually get to 360. So what I would need to do is round up, but the textbook rounded down, and I don't agree with that. So who do you trust, me or the textbook? Probably the textbook, but you know what, who cares? Okay, that's direct variation. Now, we did that last year, and so I apologize, it's going to be a long video, but direct variation isn't the only type of variation. So when two things are directly proportional, they're a constant multiple, and this is what we have. If things are inversely proportional, so two variables are inversely proportional, it's the same thing pretty much, but it's instead of one thing going up and down at the same rate, this one's going to be when one increases, the other decreases by the same factor. So think about here, if I put a 1 there, and this was 2, then this is going to be 2. These aren't going to be the same. That made no sense. Don't listen to that. So decreasing by the same factor, if they're inversely proportional, it just means y, instead of being equal to kx, it's equal to k on x. So inverse just means like, well, how can I put that in a different way? I don't know how else to think about it. Anyway, but pretty much this is exactly the same as direct. So if this was direct, you would just write equals kx. Instead, if it says inversely, you just write this. That's the only difference. Same thing. This is the constant of proportionality. This means y is inversely proportional to x. That's all that says. And I'll show you a question. Again, I'm using cars, but I just want to show you that these questions are all exactly the same. The time taken in minutes by a car to travel 100 kilometers is inversely proportional to the speed of the car. So as one goes up, one has to go down. So think about the time, so the speed of the car, the faster I go, the less time it's going to take me to get 100 kilometers. So that's pretty much what that's saying, and they're inversely. So higher the speed, less the time. Lower the speed, more the time. So they're inverse. Now, again, they give me something at the start of the question. They give me that at 50 kilometers an hour, it takes this long. So they give you one value. That happened before here. They tell you, okay, it's inversely proportional, blah, 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 and then they give you a value for each. That's so that you can come up with the equation. Now, the first question in this actually tells me to come up with the equation. I just put this in here because they say variance equation. You're like, what the hell's that? Well, that's literally just the y equals kx, or k on x. Okay. So the second it says inversely proportional, your first instinct should be, okay, I need to write y equals k on x. Now, I'm not using y's and k's. Well, I can, but let's write it as time and speed. So S is equal to K on T. I've written it that way because it makes a little bit more sense because, oh, actually no, I'd probably write it the other way. Let's see how the textbook did it. Yeah, I'd write it the other way because the speed of the car, the time taken depends on how fast I'm going. It's not the other way around, so it kind of makes sense to put this as the dependent variable. Anyway, that doesn't really matter too much. You're just going to end up with a different K value. So I just want to stress, if you were to have swapped these, your K value would be different, but the answer to these would actually be the same, and you can test that if you like. Okay, find the variance equation. So this is A, that's my equation. I'm going to fill it in with what the question's given me at the very start. So 50 kilometers an hour, 120 minutes. 50 kilometers an hour, That's the speed, 120 minutes. That's the time. That means k equals 120 times 50, which is, damn it, is it 2000? Is it 6,000? Okay, and then I rewrite my equation. So therefore, t equals 6,000 on s. That is my equation that I now use. So I like to put a box around it, preferably one that actually joins. There we go. Okay, so that's my equation. I'm gonna write that. Equation. Now for b, we start actually using the equation for b and c. So one will ask it one way, the other will ask it the other way. I guarantee it's always the same. So how long means time. Now, I just want to avoid confusion. This 100 kilometers is irrelevant. This is, the question said, how long does it take to travel 100 kilometers? So kind of forget this exists for a sec. It's how long, so t is, let me just write this. T is what I don't know. How long until, how long will it take to get there if I'm traveling at that speed? So maybe I'll write down what I have. I know the speed is 40, but t is what I don't know. So 6,000 on 40, that means t equals 600 on 4, or 600 divided by 4, 3,150. 100, or is it 15? No, 150, what is units is this in? Minutes. 150 minutes. What's that? 60, that's 2 hours, 30 minutes. 30 minutes. Is that right? Am I actually that good at maths? Yes. Okay, this next one. The car's speed. That's what I'm trying to find. Okay, so speed is what I don't know. But I do know that it took 45 minutes. So the time is 45 minutes. Again, I've got t equals 6,000 on s. S is equal to, so you can do the old swapsies. S is 6,000 on 45, which is approximately equal to 6,000 times 40. Oh, whoops, divided by 133.3 repeater. What does that mean? My speed, 133 kilometers an hour. Holy moly, that would be pretty fast and also highly illegal. Is that the right answer? Yes, it would. Okay, let me summarize. This is what the textbook gives you, and you can use it if you like, but I just want to show you that there's exactly the same thing. These are two different exercises that are pretty much identical. So solve a direct proportional. So what that means is they'll give you a spam of information, and at the very top they'll say directly proportional. You find the two variables and form an equation. So find the two variables, write an equation. Then substitute the values at the very start of the question to find k. Then rewrite your equation, then actually answer it. So that's what that says. So in other words, here's my equation. First thing I do is write it with the variables that it gives me. Then I use the information at the very start. So the information at the very start was here. Then I rewrite it using my new k value that I found. So that was the whole point, to make the equation. And then I actually answer the question. Now, I don't really like, well, these two are literally exactly the same. The only difference is this and this. So I kind of think of it like this. Make a blank equation, so blank being like this. Then use the info at the start of the question to find k. So at the very start of the question, there'll be information about these two things. Substitute them, rearrange for k. Then what you're going to do is you're going to write your equation. So remember I kept putting it in a box. Write your equation and actually write what k is. So pretend it's 2. Actually write what k is, and that's the equation that you're going to use for every question. Then you actually use it. So in other words, part A, B, or C, or whatever. That's it. So they're exactly the same. I just want to stress, whenever you see direct or inverse, you're doing the exact same thing. You're going to write an equation and then just go with that. This would be a multi-mark question. I just recognize that a question will say things like inversely variant or varies inversely or inversely proportional. That just means write this. The second you see that, write that. Again, same thing. It might say directly variant or varies directly or directly proportional. Literally just means write that, then fill stuff in. I feel like I'm saying the same thing over and over again, so I hope I haven't confused people, but it is 2 lessons in one. Next week will be a little bit of an easier lesson, so that should give people time to catch up if this lesson was a little bit too much. But I tried to give you a bit of a range of questions.